loading all the recordings, right? Yesterday's recording and today's recording, right? For those that didn't attend yesterday, we'll just have a short recap of what we did, and then we'll take it from there, right? As I mentioned, those that are online, you'll just have to follow what we're doing, because you cannot have the software on your computers, right? It's a licensed software, right? In order for you to have this software, you need to have 10,000 rands. The license costs 10,000 rands, right? But anyway, otherwise, without wasting time, we'll get started with today's session. So, yesterday, I took us through how to put on your workstations onto the working space, and we went through how to move, how to change the views, right, of your workstation from zooming into your workstation using the wheel of your mouse to changing to changing the side view, the views of your workstation, right? So just to recap, if you want to, so you have two options, right? If you want to change the views uh, of your workstation so that you can see it better. So you have the option of using the move and the rotate function here at the top, uh, uh, um, here at the ribbon, right, next to your tabs, right? So if you can click on move, you'll see that move moves your workstation to the right or either to the left at your choosing, or to the,
Sorry, sir.
yeah.
So you're not sharing your screen currently.
Oh, okay. Thanks for that. Okay. So yeah, as I was saying, in order to move about your workstations, you can use the move or the rotate function. The move function here at the top, next to this blue, I don't know if it's a hexagon or what shape, uh, you can click move, right, to move your workstation to the left or to the right, or up or down, right? And then you can choose to zoom in using the wheel of your mouse, right? And then you can also, if you want to rotate your workstation so that you can get a different view, you can do that by clicking the rotate function, right? That just rotates about your station just like that, right? And then say you want to zoom into this side, you do that by just navigating between your move and your rotate, right? Otherwise, you can always use the keyboard and your mouse. How you do that is you use the shift key if you want to move from the left to the right, top, down, right? And then if you want to rotate using your keyboard, you just click on control, you hold on it, and then you rotate about your station, right? And then yesterday we had exercises whereby we were loading a workpiece, this red workpiece, onto the chute, and then teaching the robotic arm to pick that workpiece and then place that workpiece to this slot one, where where we were testing what you call where we were testing the type of material, right? And then after testing the material, we took that workpiece to slot two, right? Uh, but we didn't successfully write the program, right, uh, on our code, right? But it's something that we'll fix today, right? So I'm going to load the the positions and the code that we and the code, the correct code, and I'll run you through it, how you how you write that code so that you can combine all the positions you inserted, right? So that you can get a full motion of your robot, right? Okay, so I'm just gonna, yes. How do you? So Agere initially, when you click on MPS system there, you'll see this station of your components. How you put that robotic station, robotic arm station, is that you'll go to modeling, and then you'll go to model libraries. Then once you click on model libraries, you'll go to Festo MPS, right? And then you'll click that arrow, and then you'll say robot assembly. You'll choose robot assembly, and then you should see your robotic arm. Are you able to see that? Okay. Combining these two, it's a matter of clicking. If you can see at the top right corner there, there's a edit mode on or off button. If you click on it, right, you can select your station like that, and then you'll see that it's highlighted in green. And then you can move about your station however you want. And then it's as easy as aligning it to that other component workstation. Yeah. And then if you're not very much accurate, the software can align for you, right? But you have to be close enough in terms of your accuracy. Are you fine? Okay. Huh? But you just came. You just came. You just came. You just have to. You just have to. Where are you lost? Hmm. Moving there. The robot station. So you are unable to connect it to that component workstation. Okay. So once you have connected the two stations, you can go out of edit mode by clicking again on that button, right? Okay. So now I'm gonna load the program along with the position list, and then we're gonna just run through the exercises that we did yesterday, right? Okay, so let me just load my files. Modeling. Okay. Open. Mm, so didn't download. Yeah. Okay, let me. You mean here under controllers? You must. Sorry. Yes. When you come to this phase under project assignment, this is where next to your project you should now select your file name, right? But you can't do that without first loading your projects. It's either you load a new project, or if you saved your project from yesterday, it's as simple as clicking on open here and then locating your project. I don't know why it's not my things are not loading onto the thought space. Uh, okay, let me do this. Uh, okay, thought space. Okay, the 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 new button, really. Because okay, I'm about to upload, and maybe I think it's a glitch on your side. If you can maybe change PC, I don't know. Uh, so it doesn't allow you to upload your things. Okay, let me upload them and maybe see if maybe it's in the sequencing of how you do it on your side, right? So I'm just gonna quickly extract. Okay, right. Then I'm just gonna copy. Okay. Okay, so your project is this one, right? Like your project file is abbreviated with .mb5, right? And then your position list is it uses the file name .pos, and then your what's this? Your project, right? Um, is identified by the file .prjx. Do you have those three files? Yeah, yeah. So if you saved successfully your file, you should see these three files, right? Um, yeah, but otherwise I'm gonna just show how to upload the files, right? So you'll click on projects and then say open. Then I'm just gonna go to my downloads, and then there you have it, robot pro1.prjx, right? And then you say open, right? And then after you do that, you will see this file. You'll see files, right, underneath that, right, with your what's this? Your main program uploaded and your position list uploaded. So immediately when you upload your file, your position list and your main program will be uploaded. So I don't know if you can try that on the PC. Okay. Okay. So we're just gonna load those two onto our screen by clicking open window. So that is the program we were writing, right? Oh no, that is not, this is the correct program. Remember yesterday our program did not run successfully, but I corrected that, and then I'll take us through how to write that code, right? Okay, I'm just gonna minimize that. And then I'm just gonna uh, place my windows in a way that is comfortable to me. Okay. Okay. So this window is your position list window, and then this window is where you write your code, right? So just to recap, this position lists are the positions that um, so these are the positions we were teaching the robot to go to, right? So we first started off with defining our position for our where the robotic arm is located by default, and then P1. So at P1 we were teaching the robot to pick, right, to pick a workpiece, right, and then at P2 we were teaching the robot to move to slot 1, right, and then we were teaching uh, the robot to go to sense the type of material, right. After teaching the robot to sense the material, we taught the robot to place that workpiece to slot 2, right. It's just that we didn't I didn't write the code successfully, right? I didn't take you through the code successfully, right? But today we'll correct that. So I'm just gonna put that at the top, and then put this at the bottom. Okay. Okay. And then I wrote a comment so that you can understand the code I was writing. Okay. So I'll first do this, right? So if I click on P100, right? Um, if I click on P100, you'll see that the robot is resting in its home position or initial position, right? Then if I can click to P1, if I can double click to P1, you'll see that the robotic arm goes to, okay, before that, let me load the workpiece. So if you want to reset, you just press this blue icon here next to the play button. Then let me just load the workpiece. How you load a workpiece is you press play, and then you press the button like that. You press the workpiece, and then it will be loaded like that, right? Now I'll just press the stop button. So this is a start and stop button at the same time. So uh, P100 is the home location, and then P1. If you double click on P1, you'll see that this is when we were teaching the robotic arm to locate, to grab the red workpiece, right? And then after grabbing the red workpiece, we moved to, okay, I forgot something. So once you are here at P1, you have to close your gripper. So at the moment it's opened. Let me show you. At the moment, your gripper is open. So if you click close here in your teaching box, you'll see that it closes, right? And then now we can press P2. We can go to P2. So as you can see, from P1, peak position, it moves to slot 1, right? I don't know, maybe I might give you the very same the very same test for lab 3, this one. Anyway, so P2 is moving to slot 1. So what is slot 1? Slot 1 is where we test the type of material, right? And then after inserting your workpiece into what you call into slot 1, we now go to the sensing part. Okay, let me just do this. So it's always important to open the gripper. So when you reach this position, what we have to do is go to our teaching box and then open our gripper. As you can see, it opens. If I click again, it closes. If I click open, it opens. And next to that close open button is your coding keyword. So for opening on your, when you are writing your code for opening your gripper, you use h open 1, and then for closing, you use h close 1. Forget the other ones, right? Don't stress yourself with those ones. So we just opened our gripper, and then what did we do? We went to let me just rotate. So yeah, this thing of rotating, guys, is just a matter of practice. Once you practice, it's just simple, right? Okay, so now we go to P3. We taught the robot to go to P3, right? So that's P3. So what is that location about? That location is about sensing the type of material, right? And then how you sense that material once you are at a so if you can observe, I'm gonna just zoom in. Your gripper, okay, there's a good position. Your gripper has a blue dot there, right? That blue dot is just the sensor, right? And then when you're sensing your workpiece, you should be at a very close distance. As you can see, it's very, very close to your material, right? To your workpiece, right? So once you are satisfied and you are at your sensor is close to your material, you just press play. You just press play. I'm just gonna press play, and then you'll see that if we look at our IO monitor, input output monitor. So by the way, that sensor is called B1_R. So since we press played, the state of the sensor should be true, meaning it's sensing the material. So how can we see that? You see that by going to the show IO monitor for current controller, right? And then if I can just extend this, if I can just extend, okay. So if you can see V1 underscore R, right? That is our sensor there on your gripper. It's saying true. What does that mean? It is successfully sensing the material, right? Then I'm gonna close that, and then I'm just gonna just check something. I'm gonna go to my teaching. If your teaching box looks like this, it means you are still you're not okay. If your teaching is like this under Cartesian coordinates, it means you haven't pressed stop here. Once you press stop, you have access to your teaching, and you are able to teach your robot to go to whichever location you want, right? Anyway, so at position 3, this is where we are sensing the type of material, and then at position 4, we now let me just do this. So after position 3, what we did is we went back to grab our workpiece. Now, what does that mean? You go back to slot 1, right? So that we can do what? So that we can close the gripper, and then so that we can close the gripper. So just go to programming, teaching, and then close, right? And then once you've closed your gripper, now we taught the robot, after closing the gripper, we taught the robot to go to where to place the workpiece onto slot 2, right? So if I can click on P4, you'll see that it takes the component and it slots it into slot number 2, right? So this is where we ended yesterday, right? Now, we were supposed to write a code. So this code, what does it do? It combines all those positions that we taught the robot, and then it puts it into motion, right? Now, we didn't write a good code because it didn't do what we had told the robot to do. But I just fixed that, and I'll just run us through uh, every line of code, right? Now, we first started by initializing our inputs, right? We defined our inputs. So we first defined, so this input here is for your sensor B2 underscore R, but this sensor is for sensing the whole of your workpiece, right? The geometry of your whole of the workpiece, right? But we didn't do that, so it's not a train smash. We shouldn't be concerned with that, right? The code will just ignore that, right? Um, Okay, so the other thing is we defined the part available equal to bit comma 2. So this is just to tell the robot that okay, so this is a sensor which informs the robot that there is a part available, right? There, here by the chute where my cursor is rotating about, right? And then we defined another sensor which is located on the gripper as B1 underscore R equals to bit 900, right? So this to sense the type of material, right? And then we had a code OVRD. So these keywords that are highlighted in, should I say blue? I'll say blue. Uh, these keywords are what you call so your commands, right? So the OVRD command is basically a command to specify the speed of your robotic arm, right? And then it's always so this 10 is at a speed of 10%, right? Now I don't know what they set it to like. I don't know if it's the speed is at uh, what's this, meters per second or kilometers per hour or whatnot. But if you set it at override, I'm at OVRD 10, you're just saying reduce the speed of the robot by, so the speed of the robot is at 10% of its total speed, right? And it's always safe to put it at 10, right? So that your robotic arm does not move, um, doesn't move quickly, right? Now we used a while keyword. So while the part available is close to 0, um, do not the robotic arm must not move, right? It will only move once the part is available at the chute, and then you end that while loop, right? By using the keyword w end, right? And then we now get to the meat of the program, right? Now, what we initially did, right, is open the gripper, right? Um, why do you want to open the gripper? You want to make sure that like your gripper is open before it can take hold of the workpiece, right? And then what we after that we said move to P1, right? Meaning move to the pick position, right? And then once you get there, once you get to P1, delay for 2 seconds, right? And then once you get to P1, close your gripper. This is what we are. So with this code, you are basically writing a code that is mimicking your positions that you taught the robot. All right. Basically, writing a code about what you did when you were teaching your robot, right? So when you get to H close one, so this is H close one. This line of code saying that close your gripper so that it can hold your workpiece, right? And then we said MVS P1 negative 30. So this line of code, I wrote the comment here. So you are moving from P1. So from P1, move out with a height of 30 units. So we have MVS and MOV. We have these two key commands, right? And you might ask yourself, what is the difference? They do a similar job, but not so similar. In that, I mean, your MVS command, it's more or less concerned with vertical um, uh, uh, vertical movement, whereas your MOV is concerned with moving from one place to the other at any height. So you can say the move function does a combination of, so it has the qualities of the MVS function, but it has also the quality of moving directly to that component. I mean to that location. Apologies for that. Okay, so here MVS P1, comma negative 30, we're saying from P1, that is from the peak position, move out with a height of 30 units. You might ask yourself, why are we moving out at a height of 30 units? So that height is to make a clearance for your component and for your robotic arm, right? So that your component does not crash into other objects, and thus preventing damage of your product. And also, you don't want your robotic arm to also be jammed. You don't want to prohibit your robotic arm from moving because it is stuck it is stuck between objects, right? So that's why we are making that height. We want to make a clearance, right, from any objects, right, near the robotic arm and the product or the workpiece. Okay, and then from there on, we move to P2 at a height of so from P1 peak position we go to P2 at a height of negative. Okay, so negative 30 in this programming language just means uh, 30 meters high, right? You would think that negative 30 goes down, but like actually it takes the robotic arm higher, right? So negative is positive in this programming language, right? Okay, so and then we're saying move P2 at a height of 30 units. Thing is, I don't know its units. I don't know if it's centimeter, meter, or yeah. Just to be safe, we just say 30 units, right? So move to P2 at a height of -30. So what is P2? According to our position list, is moving to slot 1. So we're moving to slot 1 at a height of 30. And then we're saying MVS. MVS, we're saying now, since we're at that height of 30 above our location, above our slot, now MVS P2, meaning uh, place place the workpiece to slot 1, right? Sharp. And then after placing what you call after placing your workpiece, delay by 1 second, right? Uh, so that delay is to ensure that, okay, our workpiece is successfully located at its position, right? It is correctly fitted to that position slot, right? And then we're now saying H open 1, meaning open your gripper, right? Now, so we're opening our gripper, and then after opening your gripper, you are delaying, you delay by 2 seconds. So I made a comment there saying delay by 2 seconds before moving gripper. Let me just do this. So delay by 2 seconds before moving gripper from workpiece. Right. Um, so with this line, when you're delaying by 2 seconds, you are just ensuring that, okay, we have the gripper has opened to its fullest, so that should it leave the workpiece, it doesn't come into contact with your workpiece, right? Okay, and then we're saying move so MVS P2 by a height of 30, meaning from slot 1, move gripper 30 units above workpiece at slot 1, right? And then after that, uh, move to P3. So move robotic gripper to position that senses material of workpiece, right? And then delay by 3 seconds. So this delay by 3 seconds, we are giving the robotic gripper time to sense workpiece for 3 seconds, right? And then MVS P2, uh, so move to P2 at a height of 30. So move to P2 at a height of 30 units. So remember, we are now going back to slot 1, right? After sensing, we're taking the robotic arm back to slot 1, where we'll do what? So we'll move to P2. Meaning position gripper to the workpiece. So we're positioning the gripper to the workpiece again, right? At slot 1. And then what are we doing now? We are closing. What did I do? Okay, yeah. We are closing the gripper, right? Grab workpiece by closing the gripper, and then delay for 2 seconds. So delays are important because you want to make sure that, like, in this case, you want to make sure that you have safely uh, uh, held your workpiece. Delay for 2 seconds to ensure workpiece is held by the gripper, and then move to P4. Right now, P4 is what we're placing on slot 2. So it's important to always comment so that you have a good idea, so that you can follow easily what you're doing without getting lost or confused, right? And then move P4 by a height of, so we're moving to P4 at a height of 50 units. So move to the second slot at a height of 50 units. That's my comment there, right? And then MVS P4, now you're placing workpiece directly on position 4. That is slot 2. And then once you have successfully placed your workpiece, H open your gripper, open the robotic gripper to release the workpiece, right? And then after releasing the workpiece, move P100. Uh, P100 there is what? Home position, meaning go back to your home position, right? Okay, so once you have successfully written that code, we'll now compile that code and then and then we'll observe our station here and see that if it is working correctly according to the position list and the code, right? So I'm just gonna reset there, then zoom out a bit, and then just position nicely my robotic arm. Yeah, okay. And then I'm just gonna compile. So you can compile in two ways: Control F9, or you can go to Programming and then click on Compile there at the top. Okay, so um your code will not run up until you get a message next to compilation that says one project successful, zero failed, zero skipped. In our case, we have one skipped, right? What does this one skip mean? Now, as a programmer, whatever language you're using, you should get into the habit of reading your error messages because they tend to tell you which mistake, where you went wrong, right? So we're gonna read, right? So it says at this line there, it says compilation skipped because the project is not assigned to any controller. Okay, so what does that mean? It means if you can go to what you call uh, programming and go to your project management and then go to your controllers there at the top. If you click on that drop down arrow, oh, if you can under controllers, if you click on RV2F, meaning your robot, and then you go under project assignment, next to project you will see there's no project, meaning the code doesn't know which machine are we controlling, right? So we're gonna, okay, it doesn't know the file that it's doesn't know the file name, right? There's no file name identified, right? So what you how you identify the program is by choosing the file name that you typed in, right? And then you click on it, and then you'll just close this window, and then we'll just compile again and see the kind of message we get now. So now you'll observe that it says next to compilation, one project successful, zero failed, zero skipped, meaning there are no errors. But like if there are no errors, it doesn't mean that you have written the correct program, right? That's one thing you should note, right? Now, once you've compiled, we're gonna press start, and then we're gonna load our component onto the chute. And then immediately as we load the component, the sensor tells the robot that there's a component, and then it does what we taught it now. There we go. And then once it takes the workpiece to slot number 2, it goes back to its home location, as this code informs us. And then you can end your program with the keyword end, right? And then I'm just gonna run it again because that was nice, right? So yeah, the essence of this lab, guys, is to just teach your robot, and then after you've taught your robot write commands, right? Joining all those positions that you set, and then once that's complete, you'll just fold your arms and watch your robot do the work, right? So this application, um, you can find it in settings whereby, for example, cars, like in the automotive industry. In the automotive industry, okay, not maybe not okay not let me not make an example of the automotive industry, but think of an industry whereby they're constantly changing their products, right? So sometimes if you're constantly changing your products, um, you don't have to change your workstation, but you can just manipulate your robot to use your current workstations in producing different types of products, right? So that's where teaching your robot comes in handy, right? So yeah, that's I don't know if that will bring this concept home, right? But otherwise, I'm just gonna play it again so that you can see that it follows everything that we wrote. Uh, so as it's running, you can also change the view to see a different view. Yeah. So that's that's that exercise one complete, right? So we're gonna now if we still have time, I think we still have time. We still have some 29 minutes left. So we're just gonna do exercise 2, right? Exercise 2, what that exercise 2 is about is now, um, it's now, okay, I just want to put on a different workpiece, right? I just want to load a black workpiece. Okay, I just loaded a black workpiece and I just want to see if it's gonna, okay, it's respecting, okay. Okay, okay, it's respecting our code as well, right? So now in this exercise, what we'll be trying to do is sorting. So we'll be placing two different colored workpieces into these cylindrical magazines, right? And then we're gonna sort them. By that, what do I mean? uh, the red ones will go into this into this cylinder, and then the black ones will go into this cylinder, right? But it's the same principles, right? So I'm just gonna just reduce this. Okay. Okay. So first we're gonna start by teaching the robot to take those items into the respective slots, right? So I'm just gonna do this. Change the view, and then I'm gonna press play and then load a workpiece. Now, and stop, I'm gonna stop this. Now, if you're building on this, right? If you're building on this exercise and you're loading a what you call a workpiece, and then the robotic arm starts to run that program that we wrote. How you can stop that is by pressing stop again, right? Once it starts moving, so that you can now go to that thing of so that you can start teaching it to do other things, right? We don't at the moment we don't have the time to write a code whereby it uses the panel um, to control that, right? So anyway, I'm just gonna, since it's like this, I'm just gonna take it to P1. So at P1, right? And then I'm just gonna open the teaching. So remember, what I'm doing now is teaching the robot to take this red workpiece to this slot, right? So if you yeah, if you are keen on practicing that, what you can do is initially you can write the coordinates for P100 and then write the coordinates for P1, and then we take it from there, right? Otherwise, I'm just gonna take us through that, right? So after taking your items to slot 4, let me do this. I forgot to close the gripper. Okay, I'm gonna close the gripper, and then I'm gonna take it to slot 2. I mean slot 2, which is P4, right? Sharp. So once we are there, it's just as easy as calling our teaching box, and then raising our component, right? So how you do that is by playing around with your movement axes, right? X-axis, Y-axis, and Z-axis up until you successfully load your workpiece. So we're just gonna lift that up. Okay, we're taking that down. So I'm just gonna. So as you can see, it's lifting up at big steps, right? It goes up at big steps. So if you want to be accurate, you can go to at the bottom of your teach inbox. You can say move incrementally, and then just reduce your steps, right? So you can just take it to 10 steps at a time, right? And then click enter, right? And you'll see that there's a difference now when we move it up. It's no longer going at like a high step count, right? So I'm just gonna take it up, making a clearance so that it can go into the slot, right? And then so it's very important to be able to rotate about your workstation so that you can get like a view that is you're comfortable with, so that you can see even the height clearance, right? So I'm just gonna take it a bit higher, and then start moving the robotic arm to the back, and then taking it to the side, and then changing my view, like that, and then zooming in a bit, and then taking it back, and then taking it forward. So you want to take it forward to a point whereby you are above your cylindrical magazine. Then I'm going to take it forward. And then when you're in this phase, you can now use your Y while your the letter Y on your keyboard, right? So that you can get a top view. So when you are slotting in workpieces, most of the time you need your top view, right? So you can get your top view by using uh, the control function, like that, like that, like that is your top view, right? And then you're gonna zoom in. Once you zoom in, you'll see your workpiece, and you'll see the top view of your cylindrical magazine, right? And then you'll align those two together to a point whereby the aligning is close to perfect, and then release your gripper, and thus releasing your workpiece into the magazine, right? But otherwise, if you want to do it in a different way, so if you're here and you want to get a top view, you can just press the Y letter on your keyboard. So what does the Y letter on your keyboard do? It takes you through all the sides of your workstation. So we're gonna press. So it takes us on to this view, back view, the side view, the front view, and the top view. So once you're in this position, you can just say shift um, and then move about your workpiece accordingly, right? Then we're gonna zoom in. When you zoom in, you are going through your robot in a way, and then you observe something, right? If you can, so yeah, if you can observe, right, your cylindrical magazine and your workpiece, the red workpiece and your cylindrical magazine, you observe that we are more or less accurate. We are located more or less accurately above your um, cylindrical magazine, but we're short by this space. So you can just also decrease the move incrementally to maybe 2, and then take it to, not down, take it to close that space there, that gap, like that. And then take it to the right. And then I'm just gonna rotate to see if we have covered that area nicely. So if you can see, we are almost directly over the cylinder. It's just that this portion, you need to take this portion to the top a bit, right? I see. Sharp, sharp. We Oh yeah, the test to by 12 will be out. Yes, yes. Okay, okay. So we'll just take. So now we have to align our workpiece to the cylindrical magazine, and then okay, that's not good. So this is just a matter of trial and error, guys. No one can like perfect like positioning this like uh, at like one go, right? You always have to be checking if you are at the right location. So I believe we are nicely above the cylindrical magazine, right? So I'm just gonna change the view. Then I'm just gonna zoom out, and then I'm just gonna go up a bit. Then just go to the side view. Okay. Okay. So once you're in this view, we're just gonna drop. We're just gonna do a testing to see if the cylinder is within the cylindrical magazine, and I'm just gonna drop that. Okay. Okay. So with dropping your workpiece into the cylinder, you you have to make sure that you are really deep within the hole, right? And then you'll scroll, and then just to see a closer view. So just make sure you can even go deeper. Yeah, just go deeper. As you can see, the gripper is in contact with the cylinder. You don't want that, right? Uh, okay, but because the software has a glitch, right? In this case, you don't mind that, right? Because if we just keep it at this height, sometimes it doesn't do the right things. I'll show you, right? So once we are in this location, we are at the position to be able to drop our what you call our workpiece, right? So I'm just gonna store this location. So once you're at a location you are happy at, you store that location. So under P4, we're gonna now introduce another location, and then we name this P5. We name this P5, and then this is positioning workpiece. I'm just gonna abbreviate it: workpiece above cylinder magazine. Okay, and then we're gonna click OK. Okay, and then once we're here, what we'll do is go to our teaching, and then open the gripper and see if our workpiece falls, uh, uh, goes successfully into our cylindrical magazine. If I say open, you can see that it's stuck. That's why I was saying it has a glitch. You can see that it is stuck at this position. It's not allowing the cylinder to drop down. Right? Now, how you troubleshoot that? As I said, it's by taking your. So let's close. It's by taking your. So it's by making sure that your gripper is touching your cylindrical magazine. Obviously, realistically, that's not a good thing, but that's how you troubleshoot, right? In with your virtual environment. So I'm just gonna also so this is a new position, right? So I'm gonna save this new position. So you can override the initial position that you had set by just clicking right click and say accept position. And then there'll be a few changes, right, to the position. And then I'm just gonna do that again and see if it allows the workpiece to go down. Then I'm just gonna open. So it's still not respecting that. Okay. If that's the case, we'll just take it up a bit. Okay, take it more down and see if that works. Then let me just store this location. Okay, I'm gonna call in my teaching. Okay. Okay, I just want to check something. Yeah, I'm really quite happy with the positioning of our thing, but I'm just gonna maybe shift it to this side a bit. Um, yeah, it seems okay. Right. Okay, if this doesn't work, we'll just have to call it quits, right? Um, but I'll just confirm another way to troubleshoot that. Yeah, everything looks perfect. Just doesn't want to drop the workpiece. Okay, okay. What I can do is just try to. Okay, because we saved this location, I can just maybe just go back to this location, and then take it back again to this location, right? And then just try going up and down again, up until you can go. Okay. Okay. It's embarrassing me. It's not. So we're having a glitch. It's not allowing the workpiece to go down. But otherwise, I can create after this, because the time is up. The guys are about to have a session, a test. I can create a video whereby I show you how to another way of how to troubleshoot this thing, so that it can drop into your cylindrical magazine, right? But yeah, if you have any questions, you may ask. We have 2-3 minutes before we can end the session. Do people have questions in the venue? No. Okay. And then online, does anybody have any question? Otherwise, in the absence of questions, I will end this session now. 5, 4, 3, 2, 1. Okay, no questions. All right, guys, enjoy the rest of your day. Just revise the recordings of yesterday and today, and just make some time to come to the labs and to practice, right? Since today we did yesterday's exercise. We're just correcting yesterday's exercise. Maybe you might be tested on that exercise, or I might make a recording later on how to sort those work pieces into the respective cylindrical magazines, right? And then yeah, the test will be on that. But yeah, otherwise, I believe that's it for the labs. Yeah, see you when you come for your lab 3. Yeah, that's it, guys. Oh, there's someone with a question. Yes, Lennox, you can speak or you can, yeah, type.
Good morning, sir.
Good morning to you too.
So with regards to lab test 3, so is it
Yes.
confirmed that it's gonna be writing by those who had failed the other test, or is it compulsory for all of us to write it?
About that, I spoke to your class rep, right?
Yes,
Class
sir.
reps to speak to your module lecturer. Either is it Prof? Hey, let me stop recording so that I do not say things I'll be held responsible for. Let me stop recording. Wait, what is it? Is it stopping? Okay. Stop. Okay, yeah. Now I'm at liberty to speak freely. So yeah, you